jumping back in right where we left off, we're going to create a new mono-behavior script called ground detection. This is going to be a doozy. We're going to drag it onto our player, delete the start and update method, and go really quick through this. We're going to make a header called ground detection, serialized field layer mask ground layers, and we're going to just set it to everything for now. And we're going to make another serialized field. This will be a float called ground check radius. We'll make that 0.25. Make another serialized field. This float will be our ground check distance, which we will initialize at 0.3. And then we'll do another serialized field. This will be a float, ground snap distance, 0.5. Make a new header, and this will be for gravity. There's going to be lots of serialized fields, folks. This is a bool, gravity enabled. We'll set that to true. We'll have another serialized field. This is a float called gravity acceleration. We'll have that be 25. Then we'll have another float called max fall speed, and we'll put that at 30. Then we'll make another header. This is going to be called obstacle detection, walls and stuff, as opposed to detecting the floor. This one's going to use another layer mask for obstacle layers. We will, again, just set it to everything for now. You can tweak that and change it in the editor anytime you want. If you want to have specific layers, for example, for walls or obstacles or enemies or things, if you want them to stop the player from moving, you'll want to put them on the obstacle layers. If you want the player to be able to pass through them, then you'll want to make sure they're excluded from the obstacle layers. Just like with the ground detection, we're going to have an obstacle check radius, an obstacle check distance. This one will also have obstacle check height. Basically, do you want the player to look for obstacles around where their head is at or around their feet? You can move it around, you can change its size, all that jazz. Let's make another header. We'll call this step and stair handling. We'll have a bool called step handling enabled, which we will set to true. We'll make a float called max step up height, and we'll initialize that at 0.4. We'll make another float called max step down height, which we'll have at 0.6. We'll have another float called forward ground check distance, which we'll put at 0.35. And another float called foot cast start height, which we will set at 0.5. Then we'll do another float called foot ground cast distance, which we'll put at 1.2. Another float called foot height offset, which we will just have 0 for now because I'm going to start it right around our feet. And we'll have another float called vertical adjust speed, and I'm going to start that out at 2. Now all of these values, I'm just throwing them on here. We're going to go into the editor and actually tweak them to make sure that they work the way that we want. And that is why all of these are serialized fields and not just private variables. Now with the transform up there for cast origin really quick, if you don't set it to be anything, we're just going to automatically get the current transform that this component is attached to, so the player, for example, and we'll just cast from that origin point. But if you want to create an object from which the cast will occur, you might create an empty object underneath the player in the hierarchy. You could call it cast origin point, and you could position it, at the hips, for example, and you could downward cast from there if that's what you want. Now let's make our awake method, and in here, we're going to say if animator is null, then we get the animator component. Then we'll also say if our cast origin is null, like I was saying before, we're just going to do cast origin equals transform. Now let's make the update method, which will just have inside it update grounding. And in late update, we're going to say apply vertical movement. Now let's actually create those. Private void update grounding. We're going to say vector3 origin equals cast origin dot position plus vector3 dot up times 0.1f. Then we're going to say bool hit ground equals physics dot sphere cast. Get used to seeing this. We are going to do a bunch of sphere casting stuff here. Origin, comma, ground check radius, comma, vector3 dot down, out, ground hit, ground check distance plus 0.1f, ground layers, query trigger interaction dot ignore. Now, query trigger interaction dot ignore is just so that if there's a trigger, which is supposed to basically be a zone indicated by a collider, that we don't detect that as something that should stop our movement. Now let's go private void apply vertical movement, and we'll say if gravity is not enabled, return. Just ignore this. Vector3 origin equals cast origin dot position plus vector3 dot up times 0.1f. Then we'll say bool snap hit equals physics dot sphere cast. Once again, origin, ground check radius, vector3 dot down, out, raycast hit. We'll call this one snap ground hit. Then we'll say ground snap distance plus 0.1f, ground layers, query trigger interaction dot ignore, just like before. I'm just going to clean these up a little bit so they are more legible. Then we'll go down here and say if snap hit and vertical velocity is less than or equal to 0, then float distance to ground equals snap ground hit dot distance minus 0.1f. If distance to ground is less than or equal to ground snap distance, and then inside that we're going to say if distance to ground is greater than 0.01f, transform dot position plus equals vector3 dot down times distance to ground, and then below that we'll put vertical velocity equals 0f, is grounded equals true, ground hit equals snap ground hit, and return. Then we'll say vertical velocity minus equals gravity acceleration times time dot delta time. Then we'll say vertical velocity equals mathf dot max vertical velocity negative max fall speed. And then we will go transform dot position plus equals vector3 dot up times vertical velocity times time dot delta time. And don't put the up twice. Continuing on, we'll say is grounded equals false. Now we're going to do public bool can move in direction. We're going to have it take as an argument vector3 world direction. We'll say if our obstacle detection enabled is false, return true. If world direction dot square magnitude is less than 0.00001f, return true. Then world direction dot y equals 0f, world direction dot normalize. If is blocked by wall, world direction, then we will return false. If step handling is enabled, then we're going to adjust our height to forward ground, and that will take as an argument world direction. Then just say return true. Now down here we're going to say private bool is blocked by wall, which will take as the argument vector3 world direction. We'll say vector3 origin equals cast origin dot position plus vector3 dot up times our obstacle check height. Then we'll say if physics dot sphere cast, not raycast, and you're going to get really used to this, origin, this time it's obstacle check radius, world direction, out, raycast hit, hit, obstacle check distance, obstacle layers, query trigger interaction dot ignore. Then we're going to say float wall facing dot equals vector3 dot dot negative hit dot normal world direction. If wall facing dot is greater than or equal to our wall dot threshold, then return true. And then down here, just say return false. Private void, let's make our adjust height to forward ground, which takes vector3 world direction as an argument. Once again, we'll say vector3. This will be called predicted feet position, which will be equal to our transform dot position plus our world direction times our forward ground check distance. Then we'll say vector3 cast start equals predicted feet position plus vector3 dot up times foot cast start height. Then we'll say bool found ground equals physics dot sphere cast start ground check radius vector3 dot down out raycast hit forward ground hit foot ground cast distance ground layers query trigger interaction dot ignore. If we have not found the ground, return. Then say float target foot y equals forward ground hit dot point dot y plus foot height offset. Then we'll make another float called current y, which is equal to transform dot position dot y. Then we'll make one more float, delta y, which is equal to target foot y minus current y. Now we'll say if delta y is greater than our max step up height, return. If delta y is less than our negative max step down height, also return. Then we'll say float adjusted y equals mathf dot move towards current y target foot y vertical adjust speed times time dot delta time. Whew, mouthful. All right, vector3 position equals transform.position. Position.y equals adjusted y. Transform.position equals position. Vertical velocity equals 0f. Is grounded equals true. Ground hit equals forward ground hit. Okay, that one is done. Let's go public void and make our set gravity enabled bool. This is going to just allow us in future videos to determine whether gravity should be applied or not from outside of this script. We're going to do the exact same thing for our obstacle detection. We're going to have a public method here which can be called from other scripts so that we can disable or enable obstacle detection from outside of this component. One more public void. We'll say this is reset vertical velocity, which will set our vertical velocity to 0. Okay, now this part's going to be really tedious, but it's so handy inside the editor. We're going to do private void on draw gizmo selected, and we are just going to visualize all of these different sphere casts that we've created so that in the editor it's really clear which of our checks is where, what it's going to look like, how far it really is, because all of these numbers right now are just really hard to conceptualize. So I'm not going to read all of this out. If you don't have all of this part correct, it's all still going to work. This just helps you visualize it in the editor. Now we actually need to go back into our player move script and add some things. We need a new serialized field for ground detection so that we can access this. In our awake method, we're going to say if ground detection equals null, then you can probably guess from what's above, we're going to say ground detection equals get component ground detection. Now let's go back up and create a private bool called can move input. And in our update method, we're going to say if we cannot move input, then animator.setFloat movement parameter hash should be set to 0 and return. Basically, stop trying to move the character if we're not allowed to move the character. And I'm just going to clean this up a little bit so it's easy to read, make some space here, and say vector3 desired direction equals get desired world direction. It's going to take as an argument our move input. We haven't made this method yet. We will in a moment. We're going to make a bool that says can move in desired direction equals true if ground detection does not equal null and our desired direction dot square magnitude is greater than 0.00001f, can move in desired direction equals ground detection dot can move in direction desired direction. If we cannot move in our desired direction, then movement value equals 0f. Now down here above handle rotation, we're going to make a private vector3 called get desired world direction, which will take vector2 move input as an argument. We'll say if move input dot square magnitude is less than our very small fraction, we will return vector3 dot 0. Now we can go down here in our handle rotation method, take this snippet, copy and paste that, and put it in our private vector3, and just change this return part to say vector3 dot 0. And then below that, say return desired direction dot normalize. And then back in the handle rotation method, we can delete this whole section here. It's no longer necessary. And we're going to have to tweak some things. We're going to make this vector2 into a vector3 and call it desired direction. And then we're going to make that vector2 again after the fact called move input. And we can actually just delete this float from movement value. Now we can change this movement value to our desired direction dot square magnitude to see if it is less than our tiny fraction. And that should be it for that. And then up here, there's a little thing we need to change, desired direction, move input. That's what that's taking now. So pop back into Unity, hit play, and the wall stops us. That's good news. The stairs kind of work, but not really. Having some issues here. It like works part of the way, and then every time we get to those top steps, it just falls apart and we end up slipping through it. Let's tweak some of these values. I'm going to change the max step up height to 0.6, see if that helps. Seems to help a little bit, but we're still clipping through at the top there. Yep, still clipping through. What if we change the forward ground check to be a little less aggressive? did not help. That might have made it worse. Let's change it back to 0.35. I feel like the foot cast start height is fine. The ground check is fine. Let's change the adjust speed and see if that works. Okay, that is much better. Just making it a bit more aggressive and how quickly it tweaks it is making that work really well. Now, part of the reason this is as jumpy as it is because I have colliders on every single step here. That's really not the best way to do it. You should just make a single collider that goes at an angle and then have it flatten out when there's a flatter space at the top of the stairs. We have another issue here where when we walk into the wall, you can kind of brute force your way into it and clip through it. Those are things that can be tweaked by just playing a bit more with the settings. But for now, we have working gravity. We can fall off this platform. We can be stopped by the wall. We can walk upstairs. That is pretty exciting. In the next video, we will add the ability for our character to interact with things and climb that ladder we put in there. So stay tuned for that. Thank you guys so much for watching. I appreciate you. And if you like this video and hope to see more of them in the future, please subscribe to the channel and consider subscribing to Patreon as well. You can also help support the channel by purchasing the games I've published on Steam or my book that I've published. Any of those things will help keep the channel going. Thanks so much.